Now, question 1. Question 1. Okay, so the reason I said I'm not 100% finished is because there are 2 questions in the exam where the person who made the exam made a mistake.
Okay.
So, for example, question 1 is one of those. In A1, some of you had the right answer, but I marked it wrong because the person who wrote the answer had the wrong answer.
Mm-hmm.
So I need to email him and ask him to fix it. So there were 2 questions that were wrong in the marking scheme. They were A1 and B. Oh, which one worked on? Yeah, B3, A2. No, you did. I thought you did this. B3, A2?
I didn't choose B3.
You sure?
Can't remember.
Somebody.
Oh, yeah, the last one.
Yeah, actually, I thought it was you. So, Gal, you got both these questions right, but I had to mark you wrong because the answer was wrong. I've emailed the person last week to ask if I can change your answer to right because it is right. So I think that might affect your grade. It might make you go to the next grade. I'm not sure. I won't tell you. Oh, no. That's a secret until I'm finished. Okay. Right. First question. Do you have your calculators? We need our calculators. A steel ball has a diameter of 4 millimeters. So then what's the radius? I think you all can see that the radius is 2 millimeters. What?
I remember I read 4.
Yep. Yeah. I didn't say you all got it right.
Yeah.
I think you got this wrong.
Yeah.
Yes. 2 times 10 to the minus 3.
What?
That's the radius.
Yeah.
Okay, so the first, just listen. So the first question is what's the volume? So that's 4 over 3 pi or cubed. And they want the answer in millimeters. So this would be 8 over 3, 32 over 3 pi millimeters cubed. And what is 32 over 3 pi?
I got 33.5. Check again.
I'm sure that's okay, go. Any questions? Part 2, to convert this into meters cubed. So that's 33.5 times 10 to the minus 3 cubed meters cubed. So the answer is 33.5 times 10 to the minus 9. Now, you said 6. The person who wrote the answer said 6. They made a mistake. They said 6 here instead of 9. So 9 is the correct answer. Okay.
I might read on 9. Can't remember.
You did.
9.
Yeah. 3. You have a container. It's 1 meter cubed. And my question is, or their question was, how many of these balls can you fit into container? So the answer is 1 meter cubed divided by 33.5 times 10 to the minus 9. What's that, please?
2.99?
Yeah?
I don't remember I read this.
Yeah, you didn't do this one. You skipped it and just went to 4.
What?
Which I couldn't understand because you need the answer for 3 to do the answer for 4. So you did 1, 2, 4 and you skipped 3. I don't know why you did
I
that.
remember it's a big number.
Yeah, it should be.
2.99 and 10 times power of 7.
7.
One. I didn't say this question.
I know.
Really.
Yeah. And the last part is an over or an underestimate? So their question is this n here, is this going to be too big or too small?
Too big.
Too big, yeah. Too big. Which means it's an over estimate. Yeah?
Okay.
Explain.
Explain, yeah. So what's the reason? The easiest reason is, if you think about it, there'll be a small volume in between the balls you can't use. So you could just say, there will be unused volume between the balls. I think you can give this back to me, but once I finish correcting your exams, you can have a copy of it for your notes. Do you not need to write anything down somewhere?
Take a picture.
No, I prefer to write, please.
Okay.
No, on some paper.
VALU.
Answer paper.
What?
Volume.
Volume. VOLUME. Volume. Thank you, Summer. You're so kind. Where were the two of you for the last class? On Friday?
Bad code. You know.
Sure.
It's really bad.
Is it?
Yeah.
Where were you on Friday? You missed your maths class.
Yeah, I got fever.
Did you really?
Yeah, after exam, too tired.
The only class is Friday.
Huh?
The only class is Friday.
I haven't looked at the timetable yet.
We need to just after lunch, after.
Oh, there's the thing going on, yeah.
But I watched the report, the video.
Did you really?
Yeah, you can see the
did you
history.
click like?
Yeah.
You click like?
Click what?
Like.
No, I forgot. But that's easy. We learned that in high school.
Okay. Right. They don't like my videos. Right, number 2. I think you got this one okay. What do vectors have that scalars do not?
Direction.
Direction. Now, some of you had the second one wrong. Which of those are vectors? So, velocity, yes or no?
Yes.
Yes.
Why? Velocity don't have the direction.
It does have direction. Yeah. Summer.
How about
Speed. Wait.
Oh, speed don't have the
Speed?
direction.
Look.
Oh.
Speed is a scalar. Velocity is a vector.
Okay. I right answer.
Energy.
no?
No. Force.
Yes.
Yes. Pressure.
No.
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 Acceleration.
Yes.
Yes.
So why did three rights and 2 marks? So how can I correct it?
I think it was 2 marks for all right and 1 mark for
One for the
at least 1 right, I think. What?
Pressure don't have the direction.
What's that?
Pressure
Why?
don't have the direction.
Pressure is force over area, but there's no direction in this force. It's just the size of the force
Okay.
over the area.
Okay.
Number 3. A car accelerates from rest to 25 in 10 seconds. It travels at this for 50 seconds before stopping at 75 seconds. See, I think you made a mistake here with your 50 and your 60. I think.
Yeah.
Yeah, I think you did. Time, velocity. Okay, so they want the deceleration here. So for part 2, the deceleration. So that would be 25 over 15.
No.
Yeah? 25 over 15, right? Which is 1.67 over 15.
Forget.
I think it's 1.6 repeating.
Yeah, 1.6.
And lastly, calculate the total distance.
So the area?
The area, yeah. So that would be a half 10 multiply 25 plus 50 times 25 plus 15 over 2 times 25.
I think that's 125 plus 1,250 and 187.5.
Okay?
1,562.5.
Yeah? What's wrong, Summer?
I forgot my answer. Can you tell me?
I don't remember your answer. I'm so tired, I don't remember my name.
We should write down like 1,000.
No, this is it.
Oh.
Well, no, this is what it needs to be.
What?
But total distance, they
I know, but I don't. These answer to 3 significant figures.
So that will be 1 mark.
Lose 1 mark. Yeah. Don't worry. For the next exam, you won't do this.
3 years.
No, you will remember 3 significant figures.
Okay.
All right. Right, so we've already done 1, 2, 3. Now have a look at 4. 4. A ball is kicked horizontally from an 80-meter high vertical cliff at a velocity of 15. Splash. And this is 80. What is the time it takes to hit the ground?
80.
Yeah.
And 9.
U is 0.
Yeah.
V we don't know. A is minus 9.81. T we don't know. And S is
80.
minus 80.
What? V is not 50?
No, I'm looking vertical. S equals UT plus a half A T squared. So T is 80 over 4.905 square root. What's the T?
No, I guess.
I think you're right. I think it was something like that, wasn't it?
It's 4.
Exactly?
Yeah, it's 4. Exact.
Exact?
Yeah.
I don't believe you.
4.03.
4.03.
3804 or so.
Yeah.
Only 4.
Yeah.
So 4.04.
Yes.
Oh.
Yeah, you said 4.
Yeah.
And I took a mark away.
No. I write this answer and write this equals 4.
Oh.
Maybe I have two answers.
Oh, I don't know, Summer. I'll have to think about that.
Yeah.
I'll think about
write
it.
This and
I'll think about it.
okay.
Right. They want now this distance, the range. So the range would equal 15 times 4.04. So what's that?
I just times 4.
No.
60.6.
Yeah? Okay? And then 3, they want the velocity here. So they want this and this.
That's 60.6.
Is it 60.6? Okay. Thank you. Right. Right. So, we know this one here has to be 15.
Yeah.
We need to get this one,
Yeah.
which is U plus A T. So, what is that, please, Go? That was 2. Where's your calculator, Summer? Thank you. You can help too. Ben? Calculator?
What's that?
9.81 times 4.04.
39.6.
6 what?
63.
6.3. And then this one here is 15. What they want is this
Yeah.
and this. Your answer should contain the direction.
Okay.
So, square root 39.63 squared plus 225.
Mm.
42.4.
And the direction is tan inverse 39.63 over 15.
Inverse. $69.3.
They wanted that and that.
So if I use 4 meters per second, the next answer, all the answers is wrong.
No, just some of the answer. But I don't think you did this.
Yeah, I don't did the
Yeah, so that's a problem.
Yeah, just the speed.
Continue. Okay. 3. 5. A5. A football of mass that is kicked that towards the goal. Okay, the first one you got, I think most people got this. Momentum is
Product of mass.
MV, product of mass and velocity. Yeah, very good. 2. Calculate the momentum of the ball before impact. So that's 0.65 times 28. What's that?
18.2.
18.2 kilogram meters per second. Yeah? Number 3, you all got wrong, I think. So, the change in momentum is mv minus mu, which is mv minus u, which is 0.65 minus 18 minus 28.
Minus 18.
Yeah, because first it's going this way
Yeah. Oh,
with 28, and then it's going this way with minus 18. I think you all said plus 18. Yeah. I think all of you got that wrong.
Yeah.
Because I don't think you knew this word in the question.
Rebounds?
Rebounds. What does that mean?
Rebounds. Like re is back to again.
Yeah. So why didn't you put the minus in? Yeah. Okay. Continue.
Yeah.
Ugh, I'm getting so tired. You guys make me so tired. Oh,
Is minus
thank you.
29.9.
29 point. Yeah. Oh my goodness. So tired. Okay. Continue. 6 now. The question is, what's the tensions? Can you see the picture? So, I think you all got the idea that T1 plus T2 has to equal the weight, which is 55G.
I just arrived here and no time.
Yep, I saw that. So, the next thing you can say is 1.5 T1. Well, depends where you want to take the turning force. So if I draw it here, oh, goodness sake. Okay, here. Here's T1, here's T2, and here's the weight. If I take this as the turning point, this distance here, is 1 meter. And this distance here, no, sorry, that's wrong.
No, it's not.
It's
X.
No. It's 3.5, 3.6, 3.7.
Oh,
3.7 minus 1.5. What's that? 3.7 minus 1.5. 2.2. So this distance here is 2.2, I think. And then what is this distance here? That's 7.4 minus 1.5. Ugh, what is it? 3.5? 3.5?
I mean the total.
Ah, but is this piece 3.5?
No.
You sure?
No.
What is it? No, it's not. Sorry, it's not 3.5. Sorry, 0.8 and 1.5. 1.3. 1.3. Yeah, okay. So if I take this as my turning point, I can say 2.2 times 55 times 9.81 should equal 3.5 times T2. So now I have my T2. So I have my T2.
Oh God, I got it wrong.
I know you. I think everyone got this wrong.
339.1. So just remember.
And now I need T1, please.
200.55. 201.
Hey. Is this okay somewhere?
yeah, it's okay. I'm very happy about that.
I write down the G, but after the calculator, I didn't multiply 9.84. I write down G at first.
Oh, go. Okay, 7. Everybody did a good job on 7. The force applied to the tip of a drawing pin when its pressure to the wall is 25 newtons and the area is that. What's the pressure? So pressure is force over area, which in this case is 25 over 0.35 times 10 to the minus 3 squared. So that's 25 over 0.35 times 10 to the minus 6. Yeah?
Mm.
What is it?
7 minus 4.
So 1, 2, 3, 4, 5, 6, 7, 9, 7, 1, 4, 0, 0, 0, 0, 0. 5 O's. 5 then,
I read like 7.14.
yeah. Yeah. You could say 7.14 times 10 to the 7 newtons. And I'm happy with what you wrote with number 2. Why is the pressure at the tip greater than at the head? And everybody had the same idea. Everybody was saying, well, pressure is force over area. So if you were to make the area smaller, you would make the pressure bigger. I think you all had this idea, which is good. A8.
I think the stupid question. This one. Just kinetic energy and P and K.
Yeah, that's all.
It's too long.
No, it's not. A roller coaster carriage, blah, 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 1250, the top there, okie dokie, da, 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 da. Calculate the potential energy at the top. Easy peasy. Potential energy, formula?
MGH.
MGH, the M, 1250. G, 9.81. H, 35. And the answer is somewhere?
Okay.
429. 1875.
Yeah, 0.5.
0.5?
Yeah, 0.5.
So that's 430,000 joules.
1 mark.
No, don't worry. It's only 1 mark for the whole exam.
Oh,
So if you make the rounding error, you just lose 1 mark in total.
okay.
So it's okay. It's better. Yeah. Okay, 2. What's the kinetic energy? Is it? No, what's the velocity? So you could say a half mv squared equals, yeah.
Yeah.
So that means v equals 860,000 over 1250 square root.
I didn't use N.
What?
I cancelled it.
Yeah. We can cancel that.
MGH.
Oh, I see, because you put this formula down here.
Yeah.
It's fine, yeah, same answer. Yeah, so what's this answer here?
Eight plus 8.
8.29 meters per second. What?
I said 40. He
Yeah,
puts 30.
Sorry.
That's 26.
Oh, he's useless, isn't he?
Yeah.
26.2.
26.2 meters per second. Okay. Right, 3. Yeah. What is the velocity when it's here at the top of the loop? So we want the velocity there. So we can again say 430,000 equals mgh plus a half v squared. 860,000 minus 1250 times 9.81 times 20 over 1250 square root should equal p.
First,
Oh, thank you, Ben. Sorry, that's not 20, that's 40 if I multiply by 2. Thank you, Ben.
This one. Maybe.
Did you change it to 40?
I just calculated the. I don't use this.
Yeah, okay, fine. What you get?
17.193.
I need more
Practice?
practice.
Yeah.
Boyle.
No, stop with the Chinese. What are you asking him?
I used
No, it's
another one. I used I cancelled M,
Fine.
but I got different answer.
I know, it should be the same. What answer did you get?
No. You lost the potential energy in here because here have the P and plus the Ke equals the 430, and you need to minus that one. That's the P.
Okay, so that's P plus K.
The
That's the most easy question I think I got it wrong.
The last part is at point C, the brakes are applied. Calculate the force required to stop at D, which is 25 meters away. So, the force equals MA, which equals mv minus u over t, but we don't know the t. So we won't use that formula. We could instead use UVATS. The U is 26.2. The V is 0, the A we don't know, the T we don't know, the S is 25. V equals U, no. V squared equals U squared plus 2AS. So the A is minus 26.2 squared over 50. So therefore, the F would equal minus 1250 times 26.2 squared over 50.
Can we use work equal Fs?
Yeah,
minus.
I'll show you in a moment.
I
Yeah,
got-
minus, because it's backwards. 17161 newtons?
I think maybe here my answer is wrong. Maybe I don't remember my answer.
There is another formula you can use. So you can say work equals Fs. So F would equal work over S. Now, can you type this in somewhere? 430 over 25.
Yeah, you see.
Can we-
Why is minus?
Minus?
Oh,
Oh, just because when it's
yeah,
stopping.
yeah.
That was wrong. If I didn't write down minus.
Let me see. Maybe it's okay.
And can we use like the first question? I can't remember, but maybe I just write down like 429 000 0. Not 43. Because it's 4291.
Oh, that's my mistake. I'm sorry. It's 4291, isn't it? That's my mistake. I would lose 1 mark. I should have said 429, not 430. Because it's a 1 here. Yeah, my mistake. Bad teacher. Bad teacher. I'm also useless. That's okay. We can be useless together. Yeah.
In Chinese, we have slang. If we have 3 useless people together,
Yeah.
it makes useful.
Yeah.
I think we have at least 3 useless people, so that's good. Right. A heating element which is rated at 1800 watts provides energy to 900 grams of water. The specific heat capacity is 4200 joules per kilogram per Celsius. Okay, I think you got specific heat capacity. It's the energy required to raise 1 kilogram by 1 degree.
I think I read the 1 unit of the
1 unit mass of
Yeah.
material by a unit of
Yeah, that's fine.
temperature.
That's fine, yeah. How much energy do you need to increase it to 70? So that's Q equals MC delta theta. So that's 0.9 times 4200 times 70.
Two 264,600.
264.
600.
Okay.
Okay. 1 mark.
No, 1 mark.
Oh, yeah, just the 4 total.
Yeah, total. If the kettle is 60% efficient, what's the time? So power equals work over time. So time equals work over power, which is 265,000 over, but it's not 1800.
It's
1800 times 0.6 because it's 60% efficient.
Oh. My answer is wrong because I think the 11800 is 60%.
Ah.
So I
245.
just
What is it?
245.
I can't remember. Is that okay? I use this like 60% in this way and got power and divide by.
Yeah. This is just a quickness. Oh. That's the end of section A. So how long did that take us to do? 35, 40 minutes? Who did B1? Most of you did B1. Did you like it or not?
No, because I forgot the formula.
a lot for
Yeah. Alright, A1, what's the radian? So you could say that the radian is approximately 57.3 degrees. Or, if you wanted to, you could say the radian is the angle here, so that this length is the same as this. If you want, you could say it like that. 2. Calculate the acceleration. Right, so,
No, who is so that same.
yeah, the acceleration. Right. What do we know? We know the time, we know the radius. So we could say F equals m omega squared or. Yes? Which equals, no, let me finish, which equals ma. So A equals omega squared or. So A equals 2 pi over t squared or. So then A equals 2 pi over 90 times 60. Yeah?
Oh yeah.
Times 7020,000. This equals 10.
10.
I hope so.
I
We can check, Ben.
I forgot my answer. I don't know.
Ben's checking. You check too.
No, I'm thinking about
9.5.
9.5. Yeah, so they said show that it's approximately 10. So if it's 9.5, that is roughly 10. Part 3. What's the omega? Easy peasy. 2 pi over t. 2 times 3.1415 over 90 times 60. What's that, Summer?
One point 396 10 minus 3.
And the unit?
Okay.
Radians
radian.
per second, Summer. Right, how do I calculate the force for part 4? Ah, Ben.
That's the wrong one.
Oh,
Yeah, it's wrong.
double useless. Right, go on.
It's 1.16 and power of minus 3.
Okay. Part 4, how do I get the F?
you say
Henry?
What's that, Ben?
why we don't use 10?
Yeah, good question. I think because here they say that show that the answer is approximately. I know, it's not clear, is it? 5230 newtons? Yeah? Is that right? Right. Why is there no work done?
5225.
Okay, whatever. Fine. Right, why is there no work done?
Don't have the distance. Or
Yeah, it's because, if you think about it, where's my pen go? If it's moving in a circle like this, okay, the force is this direction, and the displacement is this direction. And it's, the work is the force multiplied by the distance in the same direction. But here they're perpendicular. So it's because force is perpendicular to S and work equals force times distance, but these have to be in the same direction. So because they're perpendicular.
maybe I just write the
No, yeah, that's fine. It's just no direction. It's not because there's no force. It's just because there's no direction. Yeah. What?
I say the word definition.
You said the work definition, okay.
I don't know how to explain.
Maybe I gave you a mark, I don't know. Right, a vinyl record player plays records at a rate of 45 revolutions per minute. What is the velocity of a piece of dust on the outer edge? So you have V equals omega R. Omega is 2 pi over T R. That's 2 pi F R. Yeah? Now, you're told that's 45 revolutions per minute. That means F is equal to 45 revolutions per minute, but we want it per second. So that's 45 over 60 revolutions per second, which is, you know, per second or hertz, the same thing. So that's the F. So that means V equals 2 pi 45 over 60 times 0.18. So what is that?
I should choose the base rate.
0.848. What's wrong with you? Is it okay?
Yeah.
So the last part is what is the friction force? So F equals mv squared over r, which is 1.4 times 10 to the minus 6 times 0.848 squared over 0.18. What you get for that? Thank you, Felipe. Oh no, there's another part.
Where is the 0.18 is diameter?
Is it? Thank you, Ben.
But I also wrong because it's centimeter. I just use math.
Oh, Ben. If we did the exam together, there'd be no problem.
I think just half.
Yeah, just half it, isn't it?
Wow, what is the answer?
I forget now. Sorry.
I think it's 0.848.
So half of that.
424.
Okay. So what's the force here? Come on, Summer, type it in. I'm doing all the work. You can type. Go. Come on.
I didn't do this.
But still.
Not happy.
6 point.
6 point.
6. Multiply 10 minus 6.
Mm-hmm.
We don't say more.
Yeah, we got the same answer.
For what?
For
It's 1.4.
it's the 2.7.
Ben is wrong?
Yeah.
Okay. What is it?
2.7965 times 10 minus 4. 5.
Okay.
10 minus 5.
Why it doesn't? It's 1.4.
Yeah?
Square.
Oh.
Square.
Continue. Part C. draw the forces. Oh, yeah, easy. Here, 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 and here, the forces is like this.
Only one mark.
Yeah, only one mark. Okay.
I draw wrong, I think.
Huh?
I think maybe the answer is wrong.
Oh, okay. Okay, so the next question is here. They want to know what is the V here. The V, isn't it? So that it just about moves. So just about means here the tension is equal to 0 newtons. That's what just about means, that the tension is 0 newtons. Can you see why? So like, for example, can I have that string? That string? The green. Yeah. What is that? Oh, it's a charger. Great. So look. Think about it like this. Go. Look. Okay, this is going around in a circle. Okay? So you have a tension here. Oh, Ben. Look, please. This is going in a circle. So you have a tension force here. Okay? If it goes too slow, it will drop down. So for it to go all the way around, when it's up here, the tension must be at least 0 or more. Otherwise it would fall. Okay, so the just about means it nearly goes around.
Yeah.
And so the tension is 0. Oh no! Ben, I'm so sorry. I'm so sorry. Hang on. Ah! Here. There now. Ah. I'm so tired. I'm so sorry. I'll fix it.
This.
Oh no no no
No.
no. Oh Ben, I'm so sorry. I'm so tired. How bad is it? Is it okay?
I don't know. It's rough.
Oh, it's okay. Oh, look at this. Oh, it's okay.
Okay, just
Here. Oh, let's try and continue. Come on, go. I'm sorry, I'm so messy. I'm such a messy pig. Here, Ben. If you need tissue, there you go. Right. What was I saying? So, if you look up here, so the force here is equal to mv squared over r. And the force is also equal to mg because there's no tension. So the m's cancel and you get gr equals v squared. So v is root gr. So v is root 9.81 times 0.3. What? What's wrong? You got it wrong?
Yeah, I think this is a full question as well.
Ah, okay.
Maybe.
Go. What's this?
I use wrong formula.
For this one?
I should find this way.
1.53. You can solve integration.
1.7.
Okay. 1.72. Hey. What?
We found the calculator can solve the integration.
Yeah.
Can solve the what one? Integration?
Yeah.
And differentiation, yeah. So can the Casio, the one, I don't have it.
Or
Casting.
Yeah.
We didn't know, you know, they're like new things for us.
Yeah.
Totally new.
Okay. Continue, B2.
B2, B2, B2.
Who did B2? Yeah, right.
Ah,
What?
you do the 3.
No, I didn't do B1. I was do like
Oh,
2 when I cancelled.
Okay.
I transferred 3.
What is internal energy of the system? That is the total kinetic and potential energy of each particle.
Molecule in
Of molecule, yeah. Convert minus 15 to Kelvin, that's minus 15 plus 273.
258.
No. You all had trouble with this B part 3. Calculate the energy required for the block of ice to heat from minus 15 and turn into a gas at temperature 150.
We got
No,
problem
why?
in this?
Why?
No problem.
I think
No.
there's no problem.
It's only
Yeah.
calculate
Yeah, that's
Yeah.
really easy.
some trick.
I don't think there's problem.
Maybe some. Well, let's see. So, you have to go
Ice
minus 15 Celsius to
0.
0 Celsius.
Yeah.
And then 0 to 0.
Zero, yeah.
And then 0 to 100. Then 100 to 100.
Yeah.
And then 100 to
50.
150.
Oh, maybe it's my error. I didn't use 217 gram. I don't-
Well,
don't use
let's
it.
see. So here to here is M.
MC.
Oh my goodness.
Come.
M. C. Delta theta. And here to here is M. L.
I don't use I just
Here to here is M. C. Delta theta. Here to here is M. L. Here to here is M. C. Delta theta. Add them.
Yeah, I don't think there's a problem.
No! What answer did you get?
Not in that paper, I can't remember.
You lose 0.
Where did I lose a 0?
2, 3,
Did I? 4 zeros?
2, 2, 3.
2, 2,
2,
3.
yeah, it's 2, 2, 3.
Where's
That's
2, 2, 3?
You don't
The
lose.
four,
you
the
lose.
fourth one.
Oh, I lost a 2!
Yeah.
Not a 0. A 2. Thank you. Come on, Summer.
A411
841185.
B5.
So that's 842 kilojoules.
Huh? 1.
Sorry. 841 kilojoules.
Hmm?
Also.
Continue. Yeah. Okay. A gas which is said to be ideal follows Boyle's law. What's Boyle's law? So Boyle's law says that pressure is proportional to 1 over volume.
One more.
I even didn't know it was this.
Yeah.
The gas in a container is heated to 150. What's the new pressure? So the temperature goes from 25 to 150. That's 25 plus 273. What's that, please? To 150 plus 273. So what's this?
298.
298. And this one here?
423.
423. Yeah. So the pressure is 100 kilopascals. It should reduce. So the answer is 100 times 298 over 423. Now, look, you can also use this formula. You get the same answer.
Oh, yeah.
Yeah, so what is this answer?
Oh, 70.44.
Yeah? Continue?
Yeah.
Next part. So in this part here, some of the gas comes out. So the pressure is 120, the temperature is 150 plus 273, the volume is still 2.5, and the question is how much left? So, before I do that, I just want to do what was the number of moles at the beginning. So PV equals nRT. So N equals P V over R.
3, 1.
Thank you. T. So what's this, please? So 101 moles. Now if you go back here, if you recalculate, N equals PV over RT, what's the only thing that's different? The P is different, isn't it?
Yeah.
So that's 120,000 times 2.5 over 8.31 times the T, which is 431?
Yeah. 423.
Okay, so what's that?
$85.3.
85.3?
Yeah.
So then the delta N is that. It's the question was how many were lost.
Yeah. How many? Yeah.
Yeah, how many are required to be released?
That means
Gone, yeah.
Oh, okay.
Yeah. So what's that? 16 point.
15.7.
Yeah. Lastly, what's the mass of the CO2? So you have 15.7 moles of CO2, right?
Yeah.
So that means you have 15.7 moles of C and 15.7 moles of O2. Yeah? The atomic mass of carbon is 12 and of oxygen is 16. So this one this one is 12, and this one is 32. Yeah?
Yeah.
So it's going to be, oh yeah, so it's just going to be, if you want to add them together, 44.
Yeah.
So 15.7 times 44 grams. So what's that?
690.8.
Well, I'm wondering if I got wrong answer from the number 3. The moles was wrong because I didn't minus. So number 5, I don't have mark of the mark for the equation. I have 1 mark for equation. So I know the moles equal, mass equal moles multiplied mass.
We'll see. We got time? We have time. B3. For an electric circuit to work, a current must flow. A current is measured as the rate of flow of charged particles through a conductor. State the type of charged particles which are moving in the following. So a wire, what moves in a wire?
I don't understand this question. So I didn't try.
Okay.
I didn't.
When a current moves in this wire, what is actually moving? It's the electrons. Yeah. Current is the movement of charge. What carries the charge? The electrons carry the charge. So it's the electrons that move in the wire. An aqueous solution of sodium chloride, the ions. Yeah, you remember the picture we had in class? You had your solution and you had the cathode and the anode inside of it. Remember? No.
Chemical factory.
That's okay. Part 2 is to find the amp. And the amp is, if I remember, it's when you have 2 wires and they're separated by a distance of 1 meter in a vacuum, and their length is infinitely long, and they have no resistance. Then 1 amp is flowing if there's a force here of 2 times 10 to the minus 7 newtons, I think we said. Yeah.
Is minus 7 or minus 3?
I thought it was minus 7.
So,
Yeah. What is the base unit for the amp? The amp is 1 coulomb per second.
I should try this.
what is SI?
SI? What we did in the first lesson. There's 7 SI units. Meter, second, kilogram, coulomb, Kelvin, what else?
Current.
No.
Mole.
Oh yeah, sorry, mole and candela. So, go. 1 amp is 1 coulomb per 1 second using the SI units.
So easy.
I know, right? Okay. Calculate the charge. So what's the formula for charge? Q equals IT. What's the I? 0.05. What's the T? 120. I know, you should have done this. What's the Q?
6.
Is it 6 coulombs? Yeah, okay. B1. Describe an experiment to obtain the IV characteristic of an LED. Alright, so this is the circuit here. You have your LED. You have your voltmeter. You have your ammeter. You have your variable resistor. You have your power supply. You have your switch.
Did I right?
Don't remember.
I can't remember.
So what do? One, set up circuit as shown. 2, vary the variable resistor. 3, record pairs of I and V, because this guy gives you the I and this one gives you the V. 4, plot I against V. Yeah? Oh, and you also need to explain why you need each item. So, why do you need this one? To measure I. Why do you need this one? To measure V. Why do you need this one? Change V. Why do you need this one? Well, this gives you power. Why do you need this one? To be safe. Control too, yeah. To be safe as well. And this is the LED. Yeah. Maybe next time. Right. Describe from the diagram how the resistance changed. Right, so they want to know what happened here in the picture for the resistance between here and here. How is the resistance changing? So what's the resistance at the beginning? Well, you remember that the resistance is 1 over the slope. So what's the slope here? 0. So that's 1 over 0, which equals infinity. So at the start, between 0 and 0.6 volts, there is infinite resistance. That means no current, because it's completely blocked. And then between 0.6 and 3.6 volts, the resistance equals, what's that? That's 3 over 3, roughly. Well, 3 over 3.6 over, yeah, no, it's about 1. 1 over 1. So the resistance is 1 ohm. Okay. What is the resistivity of nichrome? So what is the resistance? Resistance equals, remember this formula? Rho L over A. Yeah, nearly finished.
Yeah, we're finished. Yeah.
So rho is 1.5 times 10 to the minus 6. L is 1.2. And A is 2.45 times 10 to the minus 7. Somewhere, please.
Yes. 2.205 and 10 minus what?
Ben?
7.3.
7.3?
4,
6.
6. 9.
Minus 3, 8, 7,
Times-
7, 5.
no,
5,
just this?
Just this.
Alright, 7.35 ohms. And finally,
I got more.
one little. say good things. This has resistance of 10 ohms. And the question is, what would happen to the resistance if the L is multiplied by 2? Well, think about the formula. R equals rho L over A.
Yeah.
So if the L is multiplied by 2, what happens? R equals
Rho
20
Oh yeah.
ohms. Okay? 2. If the length was halved and the cross-sectional area was doubled. So if the length was halved and the cross-sectional area was doubled, what would that be? What would happen? Would it be bigger or would it be smaller?
25%.
2.5, correct, Ben? It would be 2.5 ohms.
Yeah.
It would be 4 times smaller.
Oh, 3 mark.
Yeah, nice, huh? Ah?
Yeah, I just read the beginning. I can't understand what the questions meaning and.
Because you don't practice your English. Easy peasy.
I should try the B3.
You should try to practice your English. Right? Right?
I want to.
You should try to practice your English. You should read all the questions. Yes? Yeah?
How about our essay?
We shall continue it this week. I need you to finish the introduction and the main body. When's the assessment support? Have you got your timetable?
Assessments for.
It doesn't matter. Show me your timetable.
Thursday 8 9 a.m.
Let me see when we'll do it.
Thursday, there's chemistry one.
That's the
Oh,
chemistry
it's
one.
chemistry.
Friday.
No, I think maybe Wednesday.
You want to do it on Wednesday?
No, because I don't know when it's.
No, it doesn't matter. I'll just pick a class.
I will pick a class.
I'll just do whatever I want.
Okay.
Like, think about it. I'm your maths teacher and I'm your physics teacher. It doesn't matter if I could do maths and physics anytime in the week, right? It's only the 4 of you. It doesn't matter. So.
Oh, Stefan. Tomorrow,
What?
the afternoon, we have another math class for John.
No, that's a mistake. You don't have. You have 2-hour lunch.
Okay.
When do you want to do the assessments? When do you want to do the essay this week? What time? Any time. No, you have to. When do you want to do it?
Maybe Wednesday's afternoon, just one class.
Yeah.
Yeah, we can do that.
Will you have the introduction and the main body finished? Yes, you will. You were supposed to have this finished before the exams. Wednesday's class, bring your laptop if you like. Okay? Oh, so much trouble. There's still 10 minutes left. There's still 10 minutes left. Hang on. I want to think here. On your timetable, how many physics and how many maths do you have with me? How many physics and maths do you have with me, please?
1, 2, 3, 4,
No.
5, 6 physics without assessment support.
And is there a time for assessment support or is there no time for assessment support?
Without
No time.
6 class.
So 6 math, 6 physics.
So we'll have to do the essay in class then. Okay?
Why we have 3 maths?
No, you don't. That's a mistake. You don't have maths with Joan.
So this class is.
Delete.
It's not for
We have 2 hours.
With me. Like on Friday.
Yeah.
Did you watch your maths video on Friday?
Yeah, the multiplied integration.
Yeah, what's that called?
I don't know.
And it's not integration, differentiation. The product rule.
Product rule? Oh yeah, product rule, yeah, product rule, yeah. That's what we learned in high school.
Brackets.
We integrate the first one and multiply.
No, differentiate the first one. Integrate is this.
This
That's differentiate.
differentiate.
Yes, not integrate. That's the opposite. Oh, what am I going to do with you guys? You drive me nuts.
Are you correct our math exam? Or John?
John's correcting it.
Okay.
I have enough to do. I have too much to do. Oh yeah! That reminds me. This week in maths class we'll start your coursework for maths.
Oh, coursework.
Yes.
Homework.
Yeah, homework, coursework.
Oh.
So you need your laptop.
Uh-huh.
So maybe we should do the maths and the physics on the same day. Do we have maths on Wednesday as well as physics?
The morning is maths and the afternoon is physics.
Perfect. Wednesday morning we'll do the coursework for maths, and Wednesday after lunch we'll do the coursework for physics.
What's the coursework for?
You'll see on Wednesday.
Is essay also?
No. It's calculation.
I have to back home now.
Too easy. Easier than physics. Summer, Go, Ben and Khalifa, please have your introduction and main body finished for Wednesday's class, because I want to finish it this week. Because you were supposed to finish that essay before the exam, so I need to finish it soon.
Before the exam.
Yes, you were supposed to finish it before the exam, but because
When we have the exam.
Wait,
the exam, this exam.
Okay.
Yeah.
Okay.
So, right, I want to get the essay finished this week. I want to do the conclusion. Yeah, so you need to finish your piece for Wednesday. Right? Right, okay. Just go. I'm too tired to deal with you anymore.